Today we're going to talk about scientific notation. Scientific notation is used either for very large or very small numbers, and it's used to make life easier. If you have a very large number or a very small number, chances are that you're going to be writing down a lot of zeros. Scientific notation helps get rid of those zeros so it can make your life easier. It can make writing down numbers that are very large or very small much shorter. For example, the wavelength of an X-ray is a very, very small number. We usually measure them in nanometers, which is a much smaller unit than meters. But if you count the zeros here, you can see there's 3, 6, 9 places off of, or 10 places off of meters is the wavelength of an X-ray. This number would be really cumbersome to write down because of all of those zeros. You have to count and make sure you get them all. The same thing is true of numbers that are really large. We are actually going to use a number called Avogadro's number in a few weeks, and you can see how many zeros are on the end here. You could count them if you wanted. There's a lot, and again, that makes that number very cumbersome to deal with in terms of writing it down. So we can use scientific notation to make those numbers easier to work with when we're writing things down in our notes and our labs and on our homework. To change from a regular number to scientific notation, you move and count the decimal. You want to move it so that there's only one digit left in front of it. So, for example, with our wavelength of an X-ray, we would move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. You want to move the decimal so that there is one number in front of it. Move the decimal to the right 10 places, and then when you write this number in scientific notation, it becomes 1 times 10 to the negative 10th. Students sometimes have trouble with deciding whether or not the exponent should be negative. Usually they try to memorize if it goes to the right or to the left and which one of those is negative. I always look at whether or not the number that I started with is smaller than 1, is it a really small number, or is it bigger than 1? In other words, is it a very big number? Really small numbers, things that are smaller than 1, are always going to have negative exponents. Large numbers, such as this one, much, much larger than 1, are going to have positive exponents. So for this one, again, you could count, you would take your decimal from here and move it all the way to the left until there's only one digit in front of it, which would put it right between the 6 and the 0. If you count all of those places, you will end up with 23. So the decimal needs to be moved to the left 23 places. So when you write that in scientific notation, you write down the number, which would then be 6.02, and then the exponent is 23, so times 10 to the 23rd. Again, the exponent is positive because this number was much bigger than 1. If you need to go from scientific notation back to a regular number, you add zeros and move the decimal in the opposite direction. So if we took the same exact example that we had just a second ago, 1 times 10 to the negative 10 meters, this means I need to make this number smaller than 1. If it's going to get to be a smaller number, I've got to move the decimal place to the left 10 spots and fill in the missing spots with zeros. And here's the original number we started with. Same thing for our second example. If I was given this in scientific notation and needed to change it back, I would need to take the decimal from where it is and move it to the right 23 places. Total of 23 places. And if you do that, fill in with zeros, and again, you end up with our original number. It is important to be able to use scientific notation on your calculator for something that we're going to do in a few weeks, where we change the number of atoms into the number of grams, and in between something called a mole, and we'll talk about what that is. But it's important that you know how to use your calculator for scientific notation. Everybody has different calculators. I'm going to try to give you the best general directions that I can. So usually the first thing that you do is enter the number part, or the first part of your scientific notation. If we're using that second example from the previous page, you would type in 6.02 first. And then the button that you use depends on the calculator that you have. Many calculators will have an EE key, some have EXP, some have a button times 10 to the X. Either of these or any of these three buttons will work. So then you push that button and then you enter the exponent. So for example, 23, which was the exponent for this number, the example from the previous page. What I see students doing a lot, and it usually ends up messing them up in the end, is entering the 10 times whatever, or the times 10 separately. They enter it just as if they were going to do 2 times 3. They use the same sorts of keys for that. And your calculator does not read things the way you think it's going to read things. Your calculator will misread the problem. It will read the operations in the wrong order, and that will end up giving you the wrong answer. So it's important that you learn to use these shortcut keys when you're dealing with scientific notation on the calculator. If we haven't talked about Sig Figs yet, you can stop listening to this presentation here. If we have talked about Sig Figs and you're looking for a little clarification, you can start listening to the PowerPoint here. Scientific notation and Sig Figs. Significant figures are sometimes tricky or tough to figure out. Scientific notation can actually make that much easier. When you have a number that's in scientific notation, the number of sig figs is going to come from the first part, or the number part, as I like to call it, not from the exponent. In truth, you don't even have to worry about what the exponent is when you're counting sig figs for something that's in scientific notation. So here's an example. 3.25 times 10 to the 5th. If you're looking for the number of sig figs, you look just at the number part in front of the x. There are 3 sig figs here, 3 non-zero digits. So that means we don't even need to worry about the 10 to the 5th for how many sig figs are there. And again, there are 3. Here's another example. You look just at what's in front of the x, and you count everything that's in front of the x. So there's a 1, there's a 0, that's 2 digits, so 2 sig figs. So scientific notation can make sig figs much easier. You just need to count everything that's in front of the x. This does remove the confusion of 100 just a little bit more. We've talked about this in class, but if you're trying to measure something that's exactly 100, these zeros here at the end, just written the way it is, they don't indicate how much precision you had on that piece of equipment. You could have had a piece of equipment that counted by tens, here counted by hundreds, here counted by ones over here, and we don't really know. It's hard to tell what the tolerance of that instrument was just based on this number here. If you use the scientific notation version of this, that tells you much more precisely that you measured to what would be the tens place on the original number. Okay, that's it for scientific notation. Please see me if you have questions.